Hi friends, let's continue our discussion. We have seen how the size of the data is going to influence the total duration required to run the show depending on the complexity of the algorithm being used. So we have seen if n is 100 and if we are working on linear time system, say if it takes 1 second, then for a quadratic time system, it's going to take around 3 hours. And if it is an exponential system, then it's going to take around 10 to the power 20 years of time. So definitely not advisable. Then when we are working in the field of big data and all that, so today's era where we have to work on artificial intelligence where machine learning is required, and when you are learning on the machine, then the data will have a number of attributes, and commonly this n is very large. So we need to find out some way out so that these systems can be reasonably realizable. So we need to make sure that these things are realizable. So how to do? Yes, we need to find some way out, and so what the way out? So here we try to look for some magic algorithm. So that's going to give the result in some polynomial time. So assume that there is some magic algorithm which can solve our problem. So we have a problem and there is some magic algorithm which can solve this in a polynomial time. So if you assume that such a thing exists, then we are not sure whether such a thing exists or not, but assume that a solution is somehow made available to you, then one thing we can do is just verify whether the solution is correct or not. So verify the correctness of the solution. And if you can verify the correctness of the solution in polynomial time, then we can think of some solutions to this. So you're talking about a Sudoku. Yeah, definitely it's an exponential problem to solve. But if solution is available, so if somebody says this is the solution, then how much time is required to verify the correctness of the solution? So what we have to do? So look every line. So each row, look every column, and all 3 by 3 blocks. So there are 9 rows, there are 9 columns, there are 9 3 by 3 blocks, and verify whether each number is uh, present only once. If yes, then it is verified that the answer is correct. So what are we doing? So I don't know how this was solved. So somebody said that that's the answer. And if this answer is made available to us, so how much time we require to solve this? So definitely 9 rows, 9 columns, 9 these things. So totally 27 ways to work on, and there are totally 9 such things. So it's definitely how much? 3 into 9 into 9. So something 9 square into 3. So somewhere order of n square. So that's polynomial time required to verify whether the solution is correct or not. So this type of problem, now we just modify the problem from say optimum solution to a decision problem. So all other things, whatever we have seen in the previous case, whether it is 0 knapsack, traveling salesperson, or some set of some, all these problems we're trying to find the optimum solution. Now instead of finding optimum solution, just try to convert a problem into a decision problem and say, so the solution is correct or wrong. So to find that, so our say traveling salesperson problem was trying to find the optimum path. So instead of finding optimum path, we can reframe. So instead of saying find the optimum path, we can say is the given path solves the traveling salesperson problem with the less than equal to k distance. So we are given with a path. So 1 to 2, 2 to 4, 4 to 6, 6 to 7, 7 to 8, 8 to 5, 5 to 3, and 3 to 1. Some such thing is given. So that's one solution. And we just ask the question, will this solution is solvable in less than k distance? The answer will be obviously yes, if the total sum is less than k, or no if it is more than k. So this, now converting the question into finding the best path, you ask the given path, can it be solved in less than k distance? If given path, then yes, less than or equal to k, then your answer will be yes. If it is greater than k, then the answer will be no. So this type of problems now we can convert into this. Somebody magically created the path and asked us that we have a path, and we claim that this path will work with less than so much of distance. So just verify the correctness. This verification, if we can do it in polynomial time, so polynomial time verification we are doing. So exponential problem converted into a decision problem. Magical solution available. And this solution can be verified in polynomial time. Then such problem now we call NP, where N stands for non and P definitely not polynomial. It is N stands for non-deterministic polynomial algorithm. So what is it saying? That our solution for the problem was actually requiring exponential time, but we could solve that in polynomial time magically. So magically means definitely we don't know how to solve that. So we call it a non-deterministic way of solving it, because we don't know how to solve that. So we call it non-deterministic way of solving, and it is done in polynomial time. So it becomes a non-deterministic polynomial time problem. So these all problems which can be verified in polynomial time but cannot be solved in polynomial time are called NP class of problems.